Welcome to section 10.3. This is the coronavirus edition. Hope you're doing well and staying indoors. Just wanted to shore up a couple things because I won't be able to necessarily give you all that I would in a regular class, but we'll start with problem number 37. Problem 37 is circled here in blue. Pardon the noise. And I'm going to show it first by hand and then work on it a couple more ways. But the first thing that I would do in solving problem number 37 by hand is interchange these two rows right here. And so I did that, moving on down to this part of things. And from there, let's get started. What we're going to do is try and get rid of the certain elements in our system of equations. I want to get rid of the 2x here, the 5x here, and the negative y down below. And when I do that, then I'll have it in a nice form that I can finish solving. So looking at the second equation, what would I do to try and get rid of the 2x there? Well, one way is to multiply the first equation by 2 and add it to the second equation. And that's what I've done. So 2 times row 1 added to row 2, and it gives me this equation right here. Okay, let's put that aside for a second and repeat that calculation. Except this time I want to get rid of the 5 in row 3. So I'll again use the same row, except this time I'm going to multiply by 5. That should be a 5. Let's make that a 5. There we go. So multiply 5 times row 1 and add it to row 2. We can do that here. That's a really crappy 5. There we go. So 5 times row 1 added to row 2, and I've got another equation. So let's take stock of where we're at in terms of our equations. So the first row has remained unchanged. So we got negative x plus 2y minus 5z equals 6. And let me catch up with that. 2y minus 5z equals 6. And then these two new rows underlined in purple. So it's y minus 11z equals 25. And then 9y minus 26z equals 79. So, okay, well, let's keep going. What I want to do next is I want to get rid of the y here in that third equation. So how could I do that? Well, I can multiply negative 9 times row 2 and add it to row 3. So let's do that. So what's that going to look like? Well, let's think here. So it'd be negative 9 times row 2 added to row 3. And that's going to be negative 9y plus 99z equals, that'd be what, 225. And you know what, it'd be negative 225. Let's get that negative in there. And we're going to add that to 9y minus 26z equals 79. And let's see what that gives us. Well, that's going to give me 73z equals, that'd be negative 146. Perfect, perfect. So let's take stock of where we're at then. So our system of equations has now been rewritten as, let's see, negative x plus 2y minus 5z equals 6, and then y minus 11z equals 25, And then finally, 73z equals negative 146. Nice. So what's that do for us? Well, from here, we can pretty much see what z is, right? Z is equal to negative 2. Okay. So if we know z is equal to negative 2, I can plug that in here and solve for y. What do I get for y? Well, let's figure that out. This can be y minus 11 times negative 2 equals 25. Some of these are kind of horrible. There we go. 25, and that's actually a y. That's going to be y plus 22 equals 25, so y equals 3. And if we put it back in the top equation now, put that and that is the y and the z, and solve for x, I get negative x plus 2 times 3 minus 5 times negative 2. Is everything right there? Plus 2 times 3. Yes. Equals 6. And I end up with negative x plus 16 equals 6. And when you finish solving, we'll end up with x is 10. So your overall solution would be 10, 3, and negative 2. Yay, that's our solution. Wow, that was a lot of work. Our goal here is to make that work easier and more mechanical. So one way to do that is to use the program that I sent you called Row Ops. Now, for that, let's go to our TI-84 graphing calculator. And I've got in matrix D, let's take a look at matrix D, make sure it's what we look for or expect. Matrix D should be the augmented matrix corresponding to our system of equations. And it looks pretty good. Let's just peek back here at this. Right here circled in blue, and we're looking good. So with program Row Ops, if you happen to be able to download that, then this is what it's going to look like. Program Row Ops. Uh-oh. No, I guess we're not doing program Row Ops. That's a major bummer. I thought I had this loaded. Okay, well let's move on to the next part then, which is, gosh, it'd be really nice if we could speed this up and not have to do all that work with the calculation. So let's put our augmented matrix in what's called reduced row echelon form first. Now, what's row echelon form? Well, row echelon form, let's see. Row echelon form is something like this, where you've got a 1 on this kind of main diagonal and zeros below it. Now, these asterisks represent anything. These can be any numbers that you want, just as long as you have 1s on the main diagonal and zeros here. So how do we do that? Well, we could do that the way we just did with all these operations by hand, but I want to do this some other way. And that other way is to make our calculator do it. So if you go to the second button, then the math key, then over to, excuse me, I said second button, then math key. I meant second button. Let me back up here a second. And I'll clear out this key history so you can kind of follow along below a little bit better as I'm punching all these buttons. So once again, it'd be second button, then matrix, or the X inverse key is on the front, above it is the matrix. Then cursor to the right once for math, and then you can either cursor up a few times, would probably be the fastest thing. You can cursor down and get there. But we want to get to this, reduced echelon form. So let's choose that. I'll press enter. You could also type alpha and then A to get there. Now I need to tell what I need to take the reduced echelon form of, and that's matrix B, excuse me, matrix D. So hit the second key, then the matrix key. I'm just going to type in the number 4. Something in me always wants to put that right parenthesis there. You don't need it, but it's nice. And I get kind of a mess, but it's not too bad, especially if you hit the math key. You hit the math key and then press enter. Then that turns into something a little bit more understandable. So that would be this right here. And once you have it in this reduced row echelon form, it's not too bad. I mean, for instance, we see that z equals -2 right off the start. So plug in -2, multiply 3/13 by -2, add to the other side, and bam, you get y equals 3. And from there, you can plug in y equals 3 and z equals -2 and solve for x. I'm not going to do that here, but we already know that x equals 10. So great, that got a lot easier. But wait, there's more. If you noticed when we were working with this back over here, there was another option right next to REF, and it was RREF. And let's take a look at what that does when we use it with association to a matrix. So let me clear these out so that you can follow along with my keystrokes a little bit better. And I'll clear this as well. Let's go back and take a look at RREF, reduced row echelon form. So this is going to be a little bit more for us. So hit second key, then the matrix key, go over to math, and you can go up a few times. It's actually character B if you can get to that. This is the one we want, reduced row echelon form. Notice it's showing you that I went up 5 times. And I want that for matrix D. So second matrix, 4, right parenthesis, D, and bam. Take a look at what this represents now. This is your augmented matrix. It's really telling you the solution, right? Z equals -2, x equals 3, and excuse me, x equals 10, y equals 3. So there's your solution. Wow, how cool is that? Well, why don't we just do that for all our problems? Well, it might not always work out. For instance, let's take a look at problem number 37. Excuse me, not problem number 37, problem number 43. Let's move to problem number 43. Here's problem number 43. And let's see what happens when we put this in our calculator and put it in row echelon form. So let's do that. I have that stored in matrix A. You can always double check what you have in your matrices. So if you hit the second key, then the X inverse key, in this case, we'll just type number 1 and print that out. Let's compare that to what we think should be the augmented matrix for matrix A. 1, -1, 3, 3. And let's look back. Yeah, that's looking pretty good. So let's just do reduced row echelon form for matrix A. So let's see. That'd be back here to second, then matrix, then cursor over to math. Now I'm just going to hit the alpha key and then B, which is the apps button. Notice in the upper right here, to the right of apps, it gives you B. You know, I must have double hit that or something like that. It doesn't look like it's working. Let's start this again. I'll exit out of that. Oh, somehow I got reduced row echelon form. Anyways, I'll start this all over. Second, X inverse, over to the math key, hit alpha, and then the apps key. Now we need to tell it what we're taking the inverse or reduced row echelon form of. So back to second, matrix, and we wanted matrix A. Well, this is a problem. What's the last equation saying here? The last equation says 0x plus 0y plus 0z equals 1. Well, that can't be true. So what's going on? Well, what's going on is not every system of equations is going to have a solution. What we're looking at is three planes that don't intersect at a common point. So there's no solution. And that's what we're seeing when we look at the reduced row echelon form of this matrix. It's telling us no solution. No solution. So something to be aware of when you're working with reduced row echelon form. What else can happen? Well, let's look at problem number 44. So let me go back here and show you problem number 44. 44, I don't have it written out, but I do have the reduced row echelon, excuse me, I have the augmented matrix here. So this is problem number 44. And if we put it in reduced row echelon form, then we get something like this. And let's take a minute and understand what that represents. So that would represent x minus 3y, well, plus 0z, right? So equals 2. And then the next equation down below it, this one right here, represents z equals 4. All right, so great, we know what z is, but we don't have enough information to solve for y. This first equation has two unknowns, and you need, I don't know, you need something else to be able to solve for y. So the best we can do here is move that y term to the other side and say, okay, x is 3y plus 2. We don't know what y is, so we'll just leave y by itself. Y is, I don't want to write y as y. I'll just, y is whatever. So we'll just leave that there. I'm not really comfortable writing y equals y, so let me just delete that. Y is whatever, but z is 4. So your solution then would be of this form. 3y plus 2, y is whatever, and z equals 4. Now sometimes books like writing things with t here, so you could do 3t plus 2, and then t, and then 4. So that might be something that you'll see as well. But as a special bonus, for those of you who've stayed with me, let's take a look at how your calculator can help you out with this one. Now keep in mind, I already have matrix B entered into my calculator. So let's go back there, and I'll type out matrix B for you just for giggles. So second, X inverse, matrix B, looks like that. Perfect. Now we're going to go someplace that we haven't gone before, and this is the first time I've shown this to any of my math classes, so you can feel special. Hit the apps button. We want the 9th one down here, polysimult 2. So I'll type the number 9. And we want simultaneous equation solver. Now I've already got it set up for 3 equations and 3 unknowns, so we're good there. And then we'll hit the next button. To do that, you're just going to type the graph key. and I want to enter in my system of equations. Now you can do that by hand, which is fine. Nothing wrong with typing them in by hand, but let's be a little bit more clever, especially since we've already got this entered in matrix B. Notice that one of the options on the bottom is the load button. That's right above the trace key. And it's asking you to load a matrix. Well, okay. Our matrix is in matrix B. So hit second, and then X inverse, and then the 2. So it's loading matrix B. And I'll just hit the enter key. Does that look like matrix B? Yeah, looking pretty good there. And now for the coup de grace, let's solve. And wow, it gives it to you exactly the way I did. So really, really cool. All right, I hope this helps you out. In particular, the one thing that I'm going to be interested in, especially since there's things that we're not going to be doing this semester with manipulating matrices, is for you to be able to find this kind of stuff. So good luck with this. Stay safe, be well, and stay at home.